How did life begin? Did it happen more than once in the universe? The answer may lie on Mars. Mars today is desolate, dry and barren, and at first glance has little in common with our own planet. And yet from orbit, we see what look like dried up lake beds and canyons. Clues that 3 or 4 billion years ago, Mars may once have been wetter and more Earth-like. And since life blossomed here on Earth, the question is, did it ever take place on Mars? To answer this question, NASA's Jet Propulsion Laboratory brought together a team of scientists and engineers whose mission was to discover if Mars ever had what was needed to support life. A geologist and astronomer at Cornell University, Steve Squires was chosen to lead the science team. As principal investigator, he would direct the team's search for life's most essential resource, water.
I've been working on the question of water on Mars for 28 years. You can't learn what you need from a telescope. You must be a geologist.
A geologist is sort of like a detective at the scene of a crime. Something happened here a long time ago. What happened? Was it warm? Was it wet? Could life have existed here? The key is in the clues, and the clues are in the rocks.
On Earth, a geologist can find an interesting rock, crack it open with a hammer, and just look at what's inside. But we're not ready to send a human geologist to Mars yet. So we had to build a robot geologist. And the only place this could be done was NASA's Jet Propulsion Laboratory, where some of the most innovative engineers in the country work. We're talking about a robot, a rover that can go to Mars, land on the surface, take a look around, and then cut the cord and go. Carrying everything it needs with it. Cameras, instruments, communications equipment, everything. Something that can look inside rocks and that can tell us what clues those rocks hold. This place to me is almost sacred. This is the place where our rovers are assembled for the last time before they leave this planet. Everything that we do in this room must be perfect. Over 4,000 people have worked on this mission. For every single piece of this spacecraft, down to the tiniest one, there was a person somewhere who conceived it, who nurtured it, who took it from a concept to something real. It's taken this team 3 years to design and build and test these rovers, and we still have work to do. We can only launch when the 2 planets are properly aligned, and that's just a month away. But we still have tests to run. We're working in shifts. We're working almost around the clock, and we don't know if we're going to make it.
I understand everything about this vehicle. It's now bursts the bounds of our brains.
Well, this rover is more than just a roving geologist. This rover also has to be a spacecraft. It actually has to fly itself from Earth to Mars. In addition, it has to do the very subtle and quick timing control of all the things that happen as it enters and lands the vehicle. We had to stuff all that intelligence and capability into that little 6-wheel vehicle back there so that it can get there safely on its own.
I call our spacecraft the origami spacecraft, which means it's really a complicated series of folds. We had to punch holes in the lander pedals for the wheels to stand through. We've had to fold everything into these complicated shapes to get this system to fit inside this tetrahedron. It's beautiful, but at a price. And But that price in this case is complexity.
21 minutes.
There have been missions to Mars since the 60s. There have been dozens of them, but 2/3 of those missions failed. Mars is a spacecraft graveyard. A spacecraft has to travel about 300 million miles to get to Mars at about 60,000 miles an hour, but it still takes 7 months to get there. Trying to hit our landing sites from that distance is like shooting a basketball from Los Angeles to New York and having it go through the hoop without
Pause it.
touching the rim.
Possible.
The smallest mistake on our part could put the whole mission in jeopardy. 2 of the last 3 missions to Mars were failures. One spacecraft burned up in the Martian atmosphere, the other one crashed on the surface. This time, NASA decided to send 2 identical spacecraft to double our chances of success. The 2 rovers are named Spirit and Opportunity. The rovers had very different personalities. They did even when they were babies, back when we were first building them. Spirit was our troublesome firstborn. Every test we ran, it seemed that we ran on Spirit first, and the first time you try something, it usually doesn't work. So we'd run these tests on Spirit and they'd fail, and we'd try to fix things, and we'd run another test, and that would fail too. By the time we got to Opportunity, we learned stuff, and things went much more smoothly. The biggest problem is that we underestimated the size and weight of the rovers. Once we realized how big they really had to be, we also realized that the landing system we planned to use couldn't get them to the ground in one piece.
As the rover got heavier, the lander got heavier. As the lander got heavier, the aeroshell got heavier. The whole thing
It
got
is
heavier
also
and heavier and
big, I
heavier.
just still
From the very
understand.
beginning, on this mission,
Man,
it seemed like
what
nothing
the-
was going right.
The airbags are like the airbags in your car, but way more expensive. They inflate explosively around the vehicle and they cushion the landing. The first time we tested them, they tore open and deflated.
Setbacks, we know they are going to happen. I always tell people when you start these projects, the same thing probably what happened to Lewis and Clark and Captain Cook in their exploration. What is guaranteed is that there will be setbacks.
These
21,
rovers have to land using
20,
supersonic
Point
parachute.
1. 20 minutes.
The parachute design we thought would work ripped to shreds. The lander had gotten so heavy that the
I
chute
got
just
20
couldn't handle
minutes.
it. We were practically out of time, and all we had was a chute design that would destroy the
Minus,
spacecraft
please.
when we tried to land.
We had to build a whole another set of new designs. No less than 3 or 4 designs we had to test in the 3 months that followed. In our mad
Now
rush
just
to make
finish
the
it and
launch
sit.
pad.
Finish that. Finish recording.
We were running out of money.